Hello, I'm Scholastic Sam. Welcome back to my YouTube channel. Today in the class of chemistry in the unit of stoichiometry, we'll be going over lesson 4.3, mole and gram conversions. So the prerequisites are all of my other stoichiometry and chemistry videos, especially how to find molar mass. Solving steps, of course, are underline the given, box what you're looking for, then write the given, draw dimensional analysis lines, and write the units of the answer. Then you fill in the units of the conversion factors. Then you put in the numbers. Do the math, cancel the units, write, and box your answer. So if we're converting moles to grams, which you'll be doing today, you write the moles, find the molar mass of the compound, multiply by the molar mass in forms of grams per 1 mole, then you box and write your answer. But if you're converting from grams to moles, you write the given grams, find the molar mass of the compound, divide by the molar mass in the form of 1 mole per grams, and box and write the answer. Let's do some practice problems. If you haven't yet, please get your handy-dandy stylus. So, it's kind of hard for me to see. See if I can reposition this really quickly. That's big enough. Okay, so for the sake of time, I found all the molar masses, but if you don't know how to do that, please watch my other videos on it. So first, we start off with 9,289 moles NH4. Okay, simple enough. We gotta convert that to grams. So we multiply by the molar mass, which is, we see over there, it's 18 grams of NH4 per 1 mole of NH4. Now, we see that moles of NH4 cancel out, and we're left with grams of NH4, which is exactly what we wanted. Grams of NH4. Now, let's use our handy-dandy calculator, and to find the answer, we multiply 9,289 times, 289 times, times 18. All right, we get 18 times 9,289. And we get 167,202, which is equivalent to, I think that is equivalent, that's going to be equivalent to 1.672 times 10 to the 5th grams of NH4. There we go. Let's do one more practice problem. So you collect a sample of water with 17.2 grams of Mg3PO42 in it. Now that's the same as Mgp208, which we know the molar mass of using the calculator I created using Python. Is 263 grams per mole. So how many moles is it? So we 17.2. It looks like 17.2 grams of Mg3PO42. Now, so we know we have to have grams on the bottom, so we multiply by 1 mole over grams. 1 mole Mg, this is a lot to write. Mg3 PO42. We're on the bottom, 1 mole. Or no, 263 moles of Mg3 3PO42. Now, moles of Mg3PO42 cancel out, and we're left with 17.2 over 263. So we have 17.2 over 263, which is about 0.0654, which is 0.0654 is 6.54 times 10 to the negative 2 power. So we have equals 6.54 times 10, then I have 2 power, moles of Mg3PO42. Now, I think you guys are ready to go into a really hard one, known as a two-step conversion. So previously, we learned about converting between atoms and molecules to moles, and moles to atoms and molecules. And we also, in this video, we learned about converting moles to grams and grams to moles. So now, two-step conversions, though, involve converting atoms and molecules to grams or grams to atoms and molecules. So first, if you're given an atom or molecule, which are in this case, you just convert to moles and then to grams. And if you're given grams, you convert to moles and then to the atom or molecule. So yeah, the molar mass of carbon is just 12. It's already figured out for us. Yay. So we have 5 times 10 to the 22 atoms of carbon. We want to convert this to moles, so we do 6.02 times 10 to the 23rd atoms of carbon per 1 mole of carbon. And over here, we have to continue over. Now we know we want grams, so we have to cancel out the moles to get grams. We do 12 grams of carbon per 1 mole of carbon. And equals, we want our final answer to be equals grams of carbon. Let's go over. We go over here and we realize that, well, atoms of carbon cancel those out. And moles of carbon cancels out, so we can cancel those out. And we're left with grams of carbon, which is great. So we do this. So we know that this is about 5. We know that we have 5 times 10 to the 22 times 12, which is the same as 60 times 10 to the 22 power, right? Because you have 12 times 5 is just 60. But if we move the decimal point over 1 to the left, we get 6, but times 10 to the 23rd. So on the top, we get, so you could do this on the calculator either way, or in your head, either way, you get 6 times 10 to the 23rd atoms of carbon. Over that, rounded to the nearest, that's 6 times 10 to the 23rd atoms of carbon, over 6.02 times 10 to the 3rd atoms of carbon, rounded to the nearest 100, is approximately 1 gram of carbon. So if someone walks up to you on the street and is like, hey, and I have a beaker with 5 times 10 to the 22nd power atoms of carbon, how many grams is that? You'll know that's 1. Right, so I'm Scholastic Sam. Thank you guys for watching. Please remember to like, subscribe, turn on post notifications. If you have any questions, comments, or concerns, please leave them down in the comment section below. Remember, we do take video requests. Shout out to my chemistry teacher, Dr. B, for teaching me all this information. I'll see you guys next time when we talk about mole ratios. Thank you guys, bye. And always remember, knowledge is power.